So I'm going to start today's lesson by going through last week's homework. The homework that I was sent was fantastic. The majority of people were getting all of the answers correct. I'm just going to show you the answers so that you can mark your own work, and then I'll go through the answers. If when we mark them, you get all of the answers correct, then you can just fast forward this part of the video. If you didn't get them correct, or you got them right, but you're still a little bit confused about these moles tables, then watch the start of the video, and I'm going to go through each answer individually. Okay, so in question 1, these are the answers you should have filled into the box. Can I just point out at this point that when I'm doing this on my calculator, so when I do 31 divided by 7 to fill in that first box, I get an answer of 4.428571. Okay, I've rounded that to 4.43. And then when I've done this calculation, I've cleared my calculator and I've done 4.43 times 26, which is how I get an answer of 115.18. If you don't clear your calculator, you do your 31 divided by 7, and then you just multiply this number by the 26, which is more accurate, you're going to get an answer of 115.14. Okay, so you can have two different answers there, it's fine. When you're filling your number here into your tables, it's fine to just use 2 decimal places. And then I did my mass so that it was the correct number for the numbers I had in my table. If you didn't clear your calculator and you use the long decimal place and just multiplied it by 26, this number here will slightly differ. Okay, it's absolutely fine if yours is 115.14. In general, please keep your moles to 2 decimal places. Some of you rounded it to 1, so you had it as 4.4, and again, that is going to change your answer 114.4. Okay, so it's fine if you had 114.4. I said that was right, and on the mark scheme it will usually give you a range of answers that are acceptable, but in general, keep your moles to 2 decimal places, keep your mass to 2 decimal places. Okay, I've done the same thing here. I've got my moles to 2 decimal places, and then I've cleared my calculator and just multiplied 3.35 times 7 instead of the long decimal place I would have gotten when I did this original division. Okay, so they were my answers, but again, yours might differ slightly depending on how you rounded. That's absolutely fine as long as you're using the right method and your numbers are similar to mine. But do try and keep everything to 2 decimal places. This one, there's kind of no ambiguity, 1.5 and 3. I think everyone had that. The next one, again, I rounded to 2 decimal places here. So I got an answer of 54.05, but again, it's fine if that's slightly different. This one, I think if you didn't round to 2 decimal places, you got an answer of 108 instead, which is fine. Actually, yeah, I don't know. A lot of you had an answer of around 408, so I'm assuming that is dependent on how you rounded your moles. Okay, in general, keep everything to 2 decimal places if possible. They are the answers. If you got them all right, then you can just skip forward until you can no longer see my iPad on the video. If you didn't get them right or just a little bit confused, I'm going to go through each answer now. So for the first one, step 1, find moles of lithium. I've given you the formula here. To find the moles of lithium, you need the mass of lithium divided by the formula mass of lithium. In the box, I've given you the mass of lithium is 31. I've given you the formula mass is 7. So it's just mass divided by formula mass, and that equals 4.43. So to do this, I've done 31 divided by 7, and I've gotten 4.43. And I filled that box into that box there. Step 1 gets filled into this box. Okay. To work out the moles of LiF, I need to use my ratio. The ratio is 1:1. I'm getting these numbers from my balanced chemical equation. You see that there's a big number 2 in front of lithium. There's a big number 2 in front of LiF. So my original ratio is 2:2. I simplify that ratio to 1:1. What this means is that if both of these numbers are exactly the same, then these two numbers have to be exactly the same. So I calculated that this was 4.43. That means this number is 4.43. So that's my step 2, and I fill into that blue box. To get step 3, to find the mass of LiF, I need to multiply the moles of LiF, which I've just worked out, by the formula mass of LiF, and I'll get 115.18. So that calculation was 4.43, which was the moles, multiplied by 26, which is the formula mass, and that gave me my final answer. In the next table, again, find moles of LiF. So this time I'm working on this side of the table first. The mass of LiF I have is 87. The formula mass, oops, sorry, I'm right in the wrong place. The mass is 87. The formula mass is 26. So I've given that to you there. 87 divided by 26. I do that and I get 3.35. Use the ratio. The ratio is again 1:1 in its simplified form. These two numbers are the same, so these two numbers have to be the same. And I'm filling 3.35 into the blue box. To get the green box, I multiply moles by formula mass. Moles is 3.35, multiply it by 7, and you get your final answer. The next one down here, okay, for step 1, it's mass divided by formula mass again. So this is going to be 60 divided by 40, and that equals 1.5. Again, my ratio is 1:1, so these two numbers are going to be exactly the same. And then to get step 3, it's the moles times the formula mass, which is 1.5 times 2 equals 3, and I fill that into the green box. The next one is again exactly the same, okay? To find step 1, it's the mass divided by the formula mass, which is going to be 100 divided by 74. That equals 1.35. The ratio is 1:1. These two numbers will be the same, so I'm filling 1.35 into my blue box. And then to get my green box, it's the 1.35, which is my moles, times my formula mass, which is 40, and I get my final answer. Okay, the last one again, it's the same. All right, to get my green box, it's mass divided by formula mass, which is going to be 132 divided by 18, 7.3. The ratio is 1:1, so I'm going to fill 7.3 into my blue box also, and then I'm going to have my moles, 7.3, times my formula mass, which is 56, is 410.6 grams. Okay, so that's how you would work out the answers to all of the homework. So in this lesson, we are going to continue with these calculation style questions. In your homework, I filled in a lot of the table for you. I only left 3 gaps for you to fill in. In reality, when you're doing this in an exam, you have to draw the table yourself and fill everything into it. So we're going to build up, I'm just going to remove parts of the table each time so that you can build the whole table yourself and complete the full thing instead of just the 3 boxes that we worked on for homework. So this is what a question would look like. They've given you a balanced chemical equation, and then they've asked you what mass of NaCl can be produced from 150 grams of NaOH. Okay, so when you're asked about to calculate the mass and you're given an equation like this, that is when you are going to draw your table. Okay, so into my table, the things that absolutely never change is that you've got mass, formula mass, moles, and ratio. So the 3 things from your formula triangle and then ratio. So you'll always put those straight into your table. But the first decision you're going to have to make is which of these need to go into the table. Okay, so there's 2 things on the left, 2 different chemicals on the left, 2 on the right. And out of these 4 different chemicals, you need to decide which 2 you're going to put into your table, okay? And the way you'll do that is you'll look at what you're asked about and what you're given information about. So you are asked what mass of NaCl can be produced. You are being asked about NaCl, okay? So I've got NaCl here in my question. I'm being asked what mass of NaCl. That's what I'm being asked about. So that tells me that NaCl is important, and I'm going to put that into my table. And I can put that on either side of my table. I always just put the product on the right-hand side. It's just habit. It doesn't affect your answer. Can be produced from 150 grams of NaOH. I'm given information about NaOH. I am told that I've got 150 grams of NaOH. That means my NaOH is also important. Okay, so I'm putting NaOH in because I've got info about NaOH. I've got 150 grams. Okay, I'm told the mass of NaOH, so I'm given information about it. And NaCl, I'm putting it in because I'm asked about it. So that's why I'm putting those two things in my table. I'm not putting in HCl, I'm not putting in H2O because I'm not asked and I'm not given information about them. Okay, so the first step of filling in these tables for yourself is just figuring out what's important and what you're actually going to put into your table. Okay, then you need to start filling it in. Okay, mass of NaOH, we are given this in the question, 150 grams. Okay, and I'm getting this from, I'm getting this information from the question. I'm not calculating this. NaCl, that is what I'm trying to find. So that's going to be my final answer, my step 3. MR is formula mass, okay? Relative formula mass, which we learned how to calculate in lesson 1. For your homework, I calculated all of these for you, but today I want you to try and calculate them yourself as well. Okay, so remember with relative formula mass, you take the big numbers from the periodic table, because that's the mass number, and you add the mass of all the elements in the formula. Okay, so I've got NaOH. I've got 3 elements because I've got 3 capital letters. I've got sodium, oxygen, and hydrogen. Okay, the numbers from the periodic table are up here. I need to add those numbers together. Okay, so if I'm doing formula mass of NaOH, the big number next to sodium is 23. The big number next to oxygen is 16. The big number next to hydrogen is 1. And I add all of those numbers together and I get 40. Okay, so that 23 is coming from the Na. The 16 is coming from the oxygen. The 1 is coming from the hydrogen. I add those masses together and I get 40 and I put that in. Okay, you do need to be able to do that for yourself. The next one, formula mass of NaCl. I've got 2 elements. I've got sodium and I've got chlorine. The mass of sodium is 23. The mass of chlorine is 35.5. And I'm getting those numbers from the periodic table, but you will be given them in the exam question. Okay, I add those numbers together and I get 58.5 and I plug that into my table. Okay, so you will be given those numbers in the question. There they are for you, but you need to know how to use them. Okay, you'll add the different masses together to find the relative formula mass. Okay, the next step is the step that you would have completed for homework. It is finding moles of NaOH, and this is what I'm calling step 1. And to find moles, it's always mass divided by formula mass. So it's going to be 150 divided by 40. I'm going to round my answer to 2 decimal places, which is going to be 3.75. Okay, and I'm filling that into my table. 3.75, there's where I've done the calculation, 3.75. Okay, with the ratio, and this is where people tend to get confused with where I'm getting certain numbers. Okay, for the ratio, I'm filling this in using my balanced chemical equation. And to fill the numbers in for the ratio, you need to look and see what big number is in front of NaOH in my equation. So I go up and look at NaOH, and I see that there's no big number in front of NaOH. And when there's no big number in front of NaOH, I just write down 1. And then I go to NaCl in my equation, and I look for a big number, and I see that there's none. So again, I just write down 1. And that tells me my ratio is 1:1. And if both of these numbers are the same, then both of these numbers have to be the same. So if this is 3.75, then this is also 3.75. So your step 2, again, is just use that ratio to fill in your moles, okay? And that's going to be your step 2. So this is step 1, and this is step 2. And now we've just got one more box to fill in, which is going to be our step 3. And in step 3, you need to find the mass, and mass is always moles, which is 3.75 times formula mass, which is 58.5. If I do that calculation, I get 219.38 to 2 decimal places. Okay, so that's going in there. That's box 3. Okay, and that's the whole table assembled. And what this calculation tells me is if I started off with 150 grams of sodium hydroxide, I could make a maximum of 219.38 grams of sodium chloride. I'm going to get you to do one of these questions for yourself, similar to what you did for homework, but with less information, with more information to you to fill in for yourself. This is the question I want you to try by yourself. I have done some of it for you. Okay, so I've drawn the outline of your table and I've filled in the ratio. But you're going to need to find the formula mass for yourself using these numbers here. And once you've got the formula mass filled in, then you'll be following the same 3 steps that you did for homework. So pause, try this yourself, and then press play when you're ready to see the answer. Okay, so this is the final answer. The first thing you should have done was work out your formula mass. Formula mass of NaOH is 40. Sodium is 23, oxygen is 16, hydrogen is 1. Okay, and you're adding those numbers together and getting 40. For HCl, you've got 1 hydrogen, which has a mass of 1, and a chlorine, which is a mass of 35.5. I'm adding 1 and 35.5 and getting 36.5. Once I've got my formula mass filled in, I can calculate the moles of HCl. Moles is always mass divided by formula mass, so it's 200 divided by 36.5, and I get 5.48. Using my ratio, which is 1:1, I know that the moles of NaOH is also 5.48. If these numbers are the same, then these numbers are the same. Then to find the mass of NaOH, I take my moles, 5.48, and I multiply it by my formula mass, because mass equals formula mass times moles. Okay, so that's a multiplication sign, not an adding sign. I multiply 5.48 times 40 and I get 219.2 grams. That tells me if I'm starting off with 200 grams of HCl and I want the reaction to go to completion with no waste, then I'm going to want 219.2 grams of NaOH to react it with. I've got another one for you to try here. I have, again, started the table for you, but you need to fill in the rest of it yourself. Again, for calculating your formula mass, you're going to use these numbers here, which I've taken from the periodic table. So pause, have a go yourself, and then press play to see the answer. Okay, so I have filled in the answers for you, all right? I put in 300 grams here under NaCl because I'm asked how much sodium I need to make 300 grams of NaCl. So I fill in my 300 grams here. The formula mass, I'm calculating using these big numbers. So I've got 23 for sodium, 35.5 for chlorine, and I add those together and get 58.5. To find moles, it's always mass divided by formula mass. So it's going to be 300 divided by 58.5 equals 5.13. The ratio I filled in for you, the big number in front of Na is 2. The big number in front of NaCl is 2. So I ended up with a ratio of 2:2, which I simplified to 1:1. These two numbers are the same. These two numbers are going to be the same. So this is also going to be 5.3. And then to find my mass, it's going to be moles times formula mass. So 5.13 times 23 equals a mass of 117.99. Okay, if you didn't round to 2 decimal places here, then your answer might differ slightly from mine. But as long as you are getting somewhere close to the same answer as me, so if you did 300 divided by 58.5, and if you didn't round, but you left it to that, and then just multiply this by 23, then your answer will be 117.95 to 2 decimal places. So slightly different than mine, but that's absolutely fine. Okay. So in the next one, I haven't filled in very much at all. Okay, we're using a different chemical equation here, and I'm asking you how much potassium, K, is needed to make 250 grams of potassium bromide, KBr. And I haven't filled in the table, so you're going to need to do that yourself. You're going to need to look at these 3 things and figure out what you're being asked about and what you're given information about, and then you need to fill in the table. I will just give you the numbers from the periodic table. So potassium is 39, bromine is 80. So they're the numbers that you will need to calculate formula mass. You'll also need to do ratio yourself. So look at the big numbers in the balanced chemical equation and try and also fill in ratio for yourself. So press pause and have a go at filling in the full table for yourself. Okay, so in my table, I have put potassium because I am asked about potassium. How much potassium is needed? I am being asked about potassium, so I put potassium in my table. I am given information about potassium bromide, 250 grams of potassium bromide. So I'm going to put KBR in my table because I'm given info about it, okay? I'm not asked about BR2 and I'm not given information about it, so I don't put it in my table. So step one is just putting the right chemicals from the equation into your table. And I'm going to copy it exactly as it is from the equation, but notice I didn't bring the big numbers down. Now, if you did, that's fine, as long as you remember that when you're calculating formula mass, you are not going to use those big numbers, okay? So when I'm filling in my table, the first number I filled in for myself was 250 because that's the information I'm giving about potassium bromide. Then I moved down here to formula mass. Potassium has a formula mass of 39, so I wrote in 39. Potassium bromide, you've got a potassium and you've got a bromine. You add them together and you get 119, okay? I did not multiply 39 by 2, okay? So in your balanced equation, you've got this big number 2 in front of the K. You never use big numbers when you're calculating formula mass, ever, okay? And that's why I never write the big numbers into my table because I'm afraid I might confuse myself, okay? I never write them in because I don't use those big numbers when I'm calculating relative formula mass, okay? Same over here. I add 39 and the 80, but I do not multiply by 2. Those big numbers are not used for calculating relative formula mass. So it's just 39 and 119. Now I'm going to fill in my moles, so it's going to be my mass, 250 divided by my formula mass, and that gives me moles, 2.10. I need to do my ratio. I use my big numbers for ratio. That's when the big numbers become important. We don't use the big numbers for formula mass, but we do use the big numbers for ratio. So the big number in front of K is 2. The big number in front of KBR is 2. So I write in 2 and 2. I simplify that ratio to 1:1. If these two numbers are the same, then these two numbers are the same. So this is 2.10. That means this is 2.10. Once I've got this number in, I'm just multiplying these two. Moles times formula mass equals mass, 81.9 grams. So if I want to make 250 grams of potassium bromide, I would need to start with 81.9 grams of potassium. So well done if you got that one fully right by yourself. So we're just going to do 2 more. I've written out 2 questions for you, and I want you to work them out for yourself. So in the first one, I've started to draw the table. In the second one, I've given you absolutely nothing. So you're going to draw the tables just like we have been doing. You need to figure out what you're going to put in the tables, and then you're going to need to work out everything. To work out your formula mass, you will need the following numbers. You will need K is 39, O is 16, and H is 1. And once again, those numbers are coming from the periodic table. Okay, they're the mass numbers from the periodic table, and we use them to work out relative formula mass. So press pause and have a go at working out question 1 and question 2, drawing the table for yourself and filling in all of the numbers. So we'll go through the first one first. How much H2O do I need? You're being asked about H2O, so I've put H2O on my table. To react with 50 grams of K, I'm given information about K, which is potassium, so I put that into my table. Okay, filling in my mass, I'm given 50 grams of K, so I fill in 50 right here. I need to work out the formula mass for myself using the big numbers from the periodic table. Potassium, K, just has a mass of 39. But H2O, you've got 2 hydrogens, which is going to be 1 plus 1, plus 16 gives you 18. So there's 2 hydrogens there and an oxygen, which gives you a formula mass of 18 overall. To work out moles, I'm going to do 50 grams divided by 39. So 50 divided by 39 is 1.28. To get my ratio, I look at the big number in front of K, which is 2, and the big number in front of H2O, which is also 2. So my ratio is 2:2, which I simplified to 1:1. Because these 2 numbers are the same, these two numbers will be the same. So this is 1.28, this is going to be 1.28. And then to find my mass, I'm multiplying 1.28 by 18, and I'm getting 23.04 grams. And I'm rounding everything to 2 decimal places. So I do this division, I round to 2 decimal places, and then into my calculator, I'm punching 1.28 multiplied by 18 to get my final answer, which I also write to 2 decimal places. Okay, so your final answer for number 1 should be 23.04. That's the amount of water you would need to react with 50 grams of potassium. Second one, okay, same equation. And this time I'm asking you how much potassium hydroxide, KOH, is produced from 500 grams of potassium. So into my table this time, I'm going to put my potassium and I'm going to put my potassium hydroxide. And again, it doesn't matter which side of the table you put these on. Okay, I'm told I've got 500 grams of potassium. So I put in 500 grams next to the potassium. I'm asked about KOH. So this will be the last figure I fill in. Formula mass, again, potassium has a formula mass of 39. Remember, you're not multiplying by that big number, so it's just 39. KOH, you have got 39 for the potassium, 16 for the oxygen, 1 for the hydrogen. You add that all up and you get 56. Remember, you're not multiplying by that big number. To find my moles, I'm going to do 500 divided by 39, and I fill in my moles. I rounded it to 2 decimal places, 12.82. To fill in my ratio, I look at the big number in front of K and I get 2. The big number in front of KOH is also 2. So I've got 2 into 2. Simplify that ratio with 1:1. If these two numbers are the same, then these two numbers must be the same. If this is 12.82, then this is going to be 12.82. And then to find my mass at the end, it's 12.82 times 56. And this is my answer to 2 decimal places. Okay, so these questions are all done the same way. Okay, admittedly, the exam questions can be a little bit harder and maybe the way that they phrase them, but essentially you just need to be able to pick out what goes into your table and then fill in your table. To do that, you need to be able to calculate relative formula mass. And if this is causing you any bother, go back and watch video 1 again, because we are going to be consistently calculating relative formula mass throughout these calculations. Okay, so make sure you can do relative formula mass. The ratio, I'm always just getting from the big numbers from the chemical equation, and then the rest of these, there's just 2 formulas you need to know. It's always a division first, you always divide, then you use the ratio, and then you multiply. And you've got your calculator. So once you get the hang of filling in the table, it hopefully shouldn't be that much bother. Okay, so we're going to leave it there for today. In the next lesson, we are going to look at more of these table questions, but I'm going to change the ratio slightly. Okay, we've always used a 1:1 ratio. That's not the case in every chemical reaction. We're going to look at some reactions where the ratio is not 1:1, and we will look at how you deal with that.